What we started discussing in a previous video is sort of a conceptual move away from a two resistor circuit like this, which we spent a lot of time analyzing here, a classic voltage divider, where if we just put two resistors in series like this across a voltage, in the case we've been using 9-volt batteries quite a bit, and where we're sort of looking at the voltage that appears here. This is sort of our V out. And it's the voltage that always appears at the center point between the resistors relative to ground. And all these symbols here are ground. These always mean our 0-volt reference right here all the way across the bottom there. So this is what we've been using the classic voltage divider for many, many videos now. In this one here, because we're talking about capacitors, we just replaced this lower resistor with a capacitor. And we were analyzing in the last video what we see happen. Again, we're doing the same thing. We're looking for V out right here across these 2 points, just like we did with the classic voltage divider. But what we saw now is where V out here was very instant. It just appeared immediately. V out here was sort of delayed, and it changed. It gradually went up like this. In fact, if we plotted the V out as a function of time, so if this is your V here and this is time here, it started here at 0 and it gradually rose up like that. It's not a straight line. It's that rising exponential there, but that's classic for the charge or voltage when a capacitor starts to charge up like that. So we just saw the voltage sort of come up slowly. Okay, so what we'd like to do in this video then is we're just going to take this circuit here and we're just going to reverse the position of the resistor and the capacitor and see what happens then. So still a simple two-component circuit. We're still going to be looking at V out at the center point right here, but the C and the R, that is the capacitor and the resistor, have been reversed in their position. We want to look at what the voltage does here. So here's a circuit from the last video. Once again, make sure everything can be visible for you right here. There we go, get the voltmeter and the light there. Okay, here we go. So what we'll do then, a quick rehash of the last video then, is if I sort of look at the voltage across the capacitor here, I'm using my clip leads right into the voltmeter like this. So what we'll do, looks like the capacitor has a bit of charge on it already. Let's make sure it's discharged here before we start. Get it down to 0. I'm just using my screwdriver to short out the leads of the capacitor there. And so what we'll do now is let's connect the battery on a 3, 2, 1. And there's that slow rise of the voltage again. So this is what we're talking about, sort of this little graph that we sketched here, that the voltage is definitely delayed. It just comes up slowly. It doesn't always changes, keeps climbing and climbing and climbing, and it'll eventually reach the 8.5 volts. Okay, that was the last circuit. You can check out the last video for more details, just making sure we have our head screwed on right here as we start. So let's do what we said. Let's just reverse the roles of the capacitor and the resistor. So I'm still using the 1000 microfarad capacitor in here. Got that negative edge down here, because although it won't be connected directly to the negative side of the battery, it is connected more negative relative to the other side. So the negative is over here. And I'm going to take my 10K resistor again, put it in, and connect it to ground like that. And just like I did last time, we'll look at the voltage on this lower element, which in this case is the resistor, not the capacitor. And so there you go. I've just reversed them. Watch this. Here's what we'll do. We'll do a 3, 2, 1, and we'll see what happens to the voltage. 3, 2, 1, go. There we go. So it might be a little hard to assess what happened. We'll run it again in just a minute. But it looks like the voltage got high pretty quickly. And now it's dropping at about the same rate it seemed to rise in the other configuration. So let's take the battery out again, short out the leads of the capacitor and run it again. So here we go. 3, 2, 1, and go. High. Went up to about 7.5 volts, and now it's slowly coming down. So we're seeing sort of a nice asymmetry, if you will, between this circuit and the last one. Seems like when the capacitor was in the bottom, the voltage rose. When the capacitor was in the top, the voltage fell. So the point of these two videos here is to show you a bit of versatility in how you can have voltage delivered to a particular point in a circuit. You can have it rise, you can have it fall, and in the next video we'll look at the property of capacitors here that causes this rise and fall to happen. But let's just do a quick wrap up here. Sort of wrap up this video here in just a second here. What we looked at in this video versus the last one, the last video had a circuit that looked like this. There was the last video. In this video we still had our supply voltage up there, but now we put the capacitor here. And we put the resistor right here like this. And remember, this is always 0 volts down here. This is the R, has some resistance in this case. It was 10,000 ohms. The R on both these here was our 10K. So we had the brown, black, orange on there, and this was the C and this was the C. What we saw in this circuit right here is that we were going to graph the voltage we saw as time went on, it definitely rose like this. And it would take that characteristic exponential rising time that you see of capacitors. You should definitely read the Wikipedia circuit on RC circuits to see some of these graphs. In the case of this one right here, when we looked at the voltage, again, across the lower element right here, our V out was always here, between these 2 points right here. We definitely saw it start high, and it went down like that. So we can see either get a rising or a falling voltage here. And again, sort of the time that's involved with both the rise and the fall is given by the product of R times C. So either one of them can be sped up or slowed down by choosing different values of R and C. So we encourage you to repeat the 2 circuits we just looked at in this video and the last one, maybe with different values of R. You don't really have to change the C in case you don't have another capacitor, but maybe put in the 100 ohm resistor or the 2200 ohm resistor versus the 10K one that we've been using in there. But in either case, there you go. We can generate rising and falling voltages. In the next video, we'll sort of look at the property of capacitors that says why that happens.